Hi everybody, it's Jordy here, and I'm back for another YouTube video in RStudio. This is the 12th video, and quite a lot of the stuff I've done so far has been dealing with specific problems that you might face in R coding, and today will be no exception to that. I want to work with a scenario in which you want to abbreviate text. Okay, so that text could either be, or strings, let's call them strings, could either be column headings in a data frame or the strings that are actually in the columns. Okay, so the values in the columns. And there's multiple scenarios when you might want to do that. Firstly, quite often when you get data from questionnaires and or sent to you by other people, there can be way too much in the column headings and even in the columns that you don't actually need. Okay, so I've seen some recent examples of this where lots of extra information was given next to the word yes or the word no, within columns. And information that might be important, it's metadata, so to speak. You might need to know what that yes actually corresponds to in terms of the answer that was given to you, but it's not particularly useful for plotting, and you want to clean that up as well, so you don't have massive entries within a single cell. Okay, and especially for plotting, you're going to plot the column headings, so you have the option to rename column headings either before you plot them or in the labs function in ggplot. Okay, but here I'm going to show you how to do it in the data cleaning stage before you even make any graphs. Okay, so I'll give you an example, okay, of the kind of data set we might be looking at. And in this case, I'm going to make a data set and I'm going to make it in R. So for the first time, we're doing that because normally I'm bringing in data as CSV files instead of typing data directly into R, but you can make a dummy data frame in R as well, and you can do that if it's short and small. Okay, so let's make a data frame. Let's call it data, and you first want to specify that it's a data frame that you're creating. Okay, and then we, just like we did with mutate function and stuff like this, we specify the name of the column first. We're going to create 3 columns, and we'll start with the first one. Okay, so let's create a random data frame. Okay, which has different regions from different countries, and this is just a totally made up data frame, but we'll imagine we're working with 7 regions in 3 different countries, and we've got yes and no answers for each of the regions in each country. So that could refer to whatever you want it to be. It's a yes and no whether the region in that country has it. Okay, so we're just going to number the regions. We could call them things. We could call them A to G. It would be 7. Okay, but we can call them 1 to 7. With numbers, it doesn't matter whether you put these values in quotation marks, okay, because they'll still work. I generally always put words like yes and no into quotation marks, because if you don't, sometimes there can be errors. Okay, so we've got that. Remember, with the colored brackets, we can see where the C part, so to speak, should end, which will be orange here. Okay, so then we put a comma, and next we will make 3 individual countries. Okay, so these will be column headings, and if we were chatting, you could suggest to me what countries to include, but since we're not, I'll just make them up. Okay, so let's do Brazil. Okay, Brazil equals, again, the C, because we have multiple values that are going to correspond to the 7 rows, okay? And this bit's a bit tedious because we do have to put them in quotation marks. I'll put my caps lock on and make it a bit easier. Okay, again, these are just being entirely made up. It's just for the purpose of showing you how we can abbreviate words, okay, or strings, using the various tools available to us in R. Okay, so 1, 2, 3. I should have done this earlier, but it is what it is. Okay, sometimes it can be a little bit annoying to work with quotation marks. I've really experienced this before myself. We'll do a no there. And we'll do one more yes. So we just want to guarantee that we've got 7 here. 1, 2, 3, 4, 5, 6, 7. Yeah, great. At that point, we can just copy this, paste it again for another country, and I'll choose another country in that part of the world. Okay, Argentina. And I'm just going to, there's no bow in there. Okay, just going to mix up some of them. Okay, just to create again this dummy data frame. It doesn't mean anything, doesn't respond or refer to anything in particular. All right, let's take a country for the final country, which will be the 4th column, okay, that's in a different part of the world, China. And I'll call this one, well, yep, China. And I'll just, again, change some of these around. 15 minutes later. Okay, call this one though. Right, so that's done now. We've finished on a pink bracket. The pink bracket should end it as it starts it, and that's why we use the rainbow parenthesis, so we can see that. So we need to put data.frame, of course. Okay, so now we can just view that data frame just by view data, and we've created a small data frame in R, and that's what we're going to work with. And the idea is to show you how we can abbreviate both the names of the columns from region to China, and then in the second part how we can abbreviate the yes to Y and the no to N. Okay, what is shown right now isn't particularly a problematic data set or anything. It's not complicated, it's not messy, but the same rule would apply if it was to say yes dot there are eagles in this region, okay, or no dot there are no eagles in the region, or anything. Okay, so we'll go back to the script we're creating here, and we'll start with abbreviating the names. Okay, so firstly, it's useful to make a copy of that data frame. I'm always doing that just to keep things nice and clean. Main reason being, if we wanted to go back to the original data, we can still do so. Okay. Now we've created that new data frame, and we can work with changing the headers. What I'd like to do is to change these headers, region, Brazil, Argentina, and China, into abbreviated names. Okay, so again, it's not really required for this data frame because these words aren't too long, but other cases they might be long questions, for example, or much more information in the headers than is actually required. For the purpose of this, let's take first 3 letters of every word. Okay, so region will become reg, Brazil will become bra, Argentina will become arg, okay, and China will become chai. Okay, so we first create an object, and that object is going to refer to the new names. Okay, you could call this whatever we like, just like you can name any data frame like this, whatever you like. But it makes sense to keep it something that relates to what you're actually doing in that code. Okay. right? It's back arrow of substr. You'll see here that it says base. So this is a base R codes. Means that we don't need any libraries, specific libraries like tidyverse to do it. But we will use tidyverse in the next part. And that's why I always recommend to have tidyverse running at the top of every single script. It's really the most useful library in R. Okay. The next part is brackets names. Okay. Names is part of the code, right? So that's something that you can't change, that is kind of inbuilt for changing column names. Then you specify the data that you're referring to, okay? And we introduce square brackets. So square brackets, again, we've seen them before, are a key symbol within base R. And anytime you see them, you're generally working with base R. Okay, you specify the columns that you're referring to here. And we could do that a couple of ways. We could do that with the names of the columns, or we can do it with the numbers of the columns. And I'm these days using numbers of columns much more often. This works very well when the columns are in order, you know, so they are in this case. They're columns 1, colon, not semicolon, colon 4. Okay, so we're talking about columns 1 to 4, and in this part we specify what we actually want to do. And this part goes back to the substr. Okay, think of that as an abbreviation code. We're going to need two numbers, just two numbers. And those two numbers refer to the first letter or first character or first digit that we want to present, and the second number refers to the last one that we want to present. So that's going to be 1 and 3. Okay, I'm going to close that before I forget to do so. We actually don't need to, because we've got a pink here and a pink here, and that's what we're looking for. Remember that the this 1 to 3 will refer to R to G and B to A, etc. So we run that. No warning or error has been detected, which is great. That's an object now. And what does an object mean? It means that when you just type in the name of the object, it will appear in the console. So it looks good. We've changed these now. So reg, bra, arg, and chai. Okay. Now what we need to do is we need to apply these names to the data. Okay. So names data to is back arrow of that object. Okay. So basically saying this object is what we now want to put as the names of the data to. Because at this point, incidentally, if you were to just view data to, sorry, my bad, view data to without doing this stage, it hasn't changed yet. Okay, so we're just going to, oh, sorry, I haven't ran it yet. We're just going to run it first, and we'll see it has not changed yet until we do this stage here. And then view the data to after this. Okay. Now it's updated. So that's great. That's useful for the column headings. For me anyway, it hasn't worked too well for changing any of the text here in the columns, okay? So for this, I've had much more luck anyway with using the pipe function, okay? The column contents. And again, the idea here would be that we turn yes into Y and no into N, you know, again, making these words shorter. Okay, so now we're going to work on the column contents. And for this, we'll use the pipe function and the mutate function, okay? You might remember we introduced the mutate function in a search back for it. It was in this one, right? It was in the fourth video, okay? we used it here. So we used a bunch of examples. Mutate with case when. We'll take the mutate part, not the case when part here. Like in this case with empty cars, what we did was like this part here, okay? We created, I guess mutate is kind of the same as create, a column called weight 100 code, which was this, it's like a code, right, that we're creating, where we were referring to two different ranges in the weight 100 column, okay, as group A and group B. It's this part that we're going to pay attention to here. And if you've been Googling mutate function, you'll see that there's various variations of it. Okay, there's mutate across. Okay, the across part would go here. Okay, something like this. And if you're just working with, you know, mutate across, it's actually just as good, if not better, than working with mutate. So I really recommend just get in the habit of using mutate across. And that's probably what we'll use from now on, because mutate across works for if you're referring to a single column. In this case, we refer to a single column, the WT100 code, or if you're referring to multiple columns. So it works for both. Mutate by itself only refers to one column. Okay, so mutate across is better than mutate for working with lots of different types of scenarios. Okay, so let's make a data free here is based on data, the world famous pipe function. Mutate across. Okay, now we're going to refer to the columns 1 to 4, just like we did earlier for the names. We want to change all the yeses to y's in all 4 columns, and we want to change all the no's to n's in all 4 columns. Okay. Slight difference in the dplyr, okay, pipe function code compared to base R, because we don't use square brackets here. Okay, we don't use the C round brackets 1 to 4, like this. Square brackets won't work here. I'll show you later what happens if we try to do that. And then what we want to do is, after the orange one, is put a comma. Now we're going to go into a new line. Okay, so we finished that line on a comma. This is a line that refers to the data in question. It's a bit like in ggplot, you know, your first line of ggplot refers to the data that you want to plot, and then the next lines go on to the type of graph you want to make and other details. Okay. This is introducing you now to function, because if we want to do this for multiple columns at once, 1 to 4, we would use the function codes. That's one of the options. Okay. It just means that we want to make the following step, okay, where we actually write the change or the code that refers to the change we want to do, okay, i.e. the yes to the y, the no's to the n's. We want to make it apply to columns 1 to 4. Okay, that is also a very useful time to learn about functions, because it allows you to do the same thing to lots and lots of columns, and you might find yourself doing that in your own project. Okay, then we do the same or a very similar version of the substr thing. Don't worry about like the synchronicity of spaces and any of this, it doesn't really matter. Okay, substr. Then instead of this part, okay, instead of any of this, we just replace this with x. Okay, and then we do 1. We could try 1 to 3. 1 to 3 would give us the yes, and it would give no space, but we don't want that. We want 1 to 1, because in this case we're just wanting the first letter of the yes and the first letter of the no. So something like this should work. Again, remember, this is the first character, digit, number, whatever, and this is the last digit, character, number, whatever. tried that and it didn't run, and I realized why. This is just a little annoying thing, okay? In this one, what you want to do is you want to not have the closing orange bracket in the first line, okay? So this keeps it all together, okay? We only have the open orange bracket, okay? And then we finish on a comma. And then we finish, of course, on the pink because we start on a pink. Don't worry about necessarily remembering all that. Sometimes brackets can be really difficult, to remember, especially if you're beginning. What do you put in each part? Sometimes it's trial and error, but if you have the code, and you can message me in the comments for the code if you like, or you can just copy this. Then you just need to apply this every single time, okay? We never finish on an orange or a pink in the first line. We just have it like this, and then it will work. Let me just do this on data2 instead of data so that we retain the new names as well. Okay, so now we're going to view data3. This should hopefully include the changes we already made to the names in data2, plus these changes that we're making to the yes and no in data3. Sorted. So now we've abbreviated the names of the columns and also the yes to y and no to an n. As a reminder, it's not essential for the data frame we're working with, but it might be for yours. What else? The other thing is, if you had tons and tons of columns, like hundreds, that you wanted to do this to, you would just, we don't have 100 here, but you would just update this to 100. And that's when R gets very, very useful. Because try to do that yourself in Excel, and you might still be here next year. And you would also have a massive migraine. And as somebody who gets migraines frequently, I definitely do not recommend them. Okay, the last thing I wanted to show you was a scenario, and we're just playing around here with the data, okay, where we would modify this code slightly. The first three lines would stay the same, okay, the creating a copy of the data, the columns we're referring to, and this function that refers to, this part, to perform this part. Okay, we just change this part here. Okay, so we can use this general format for doing a bunch of changes, including one called string remove. So instead of substr, we could use string remove, and string remove is really, really useful if you've got messy stuff, characters, numbers that you don't want in your data and you want to remove them. Okay, you want to remove them from the strings. We don't have anything dirty in this that we want to take out necessarily, but as a scenario or as an example, we could remove the y's and the n's. Okay, I'll show you how to do that. So let's copy the whole thing. Removing stuff from column contents. Let me do data 4 is based on data 3. Keep these two the same. Change this to string, and see, we start now. This is string R. Okay, so if you want to use functions like string remove, string replace, you definitely need to have string R, and you get that through tidyverse. Okay, so you don't need to load that one manually, individually. You can bring that in through tidyverse. String remove from X, of course, okay, from this, columns 1 to 4. We are going to, in one of the kind of rare scenarios where you would use square brackets in the pipe function, we're going to use it here. And we just can put this in square brackets for now, and then we can write the things that we want to take out. And you can just, you can just write them in a straight line, no spaces. Here we take out y and n, okay? That doesn't necessarily mean that there is a word that says yn. That means that we are going to take out every y and every n. We can add something else in there too. Imagine there's a 1, okay? That's something else that we can take out, or a 2 or a 3. We don't have 1s or 2s or 3s, but it's okay to have stuff in there to be excluded, to be removed if it exists, okay? And that is one of the most useful bits of code for cleaning your data. Let me see. Unexpected square bracket, why would that be? That's because, and that's my bad here, we don't have the apostrophes, the quotation marks inside the square brackets. We have it outside of the square brackets. Boom. So that's actually taken out, oh yeah, I forgot we did actually have a 1. We had a 1 in the region, okay? Let me see if we take out that 1 and try now with just yn. Just a second. Okay, yeah, of course, it took out all the y's and all the n's, and we can also include the 1. We can take out the y's, n's, and 1's. I forgot that we only had y and n in that data frame, you know, so I got a bit shocked when it went blank. Let's do it, okay, on data 2, because this will show you now that it leaves the other contents of the word with the exception of the y and the n. So we still had yes and no in data 2. We should be left with es and o in data 4. Sorted. Okay. So obviously that makes no sense at all, and we have kind of totally messed up the data by doing it, but this might give you an example, this would give you an example of how you could remove symbols, numbers, other things from your data that you don't want there. Okay, and that's a very useful tool that would be much faster to do with this code than it would be with Excel, just like in the previous steps as well. So that's all I wanted to show you today. We've obviously been able to change the appearance of the data by doing this, and that's what tidyverse and the pipe function as well as substr allow you to do. In the next one, I am going to do something a little different. Let's make some maps. Okay, you might need maps for various projects in demographics, politics, marine biology, and hopefully that should help you. I'll try and get that one out in the next few days, guys. If you're enjoying this series, please like the video, please subscribe to the video, and please share if you've got any colleagues or friends that might be interested too. I wish you the best, and I'll see you later. Bye.